everyone. I'm going to start this video off with the same slide that I was on at the end of the previous video. So in the previous video, we talked about margin of error and the confidence level. And we said that the larger the confidence level, the larger the error, the bigger the target, in order to be confident that we're going to find that true proportion. Well, the other thing that can affect the margin of error, if we want to keep the confidence level the same, is the sample size. So remember way back when I was talking about sampling distributions, and we had a sampling distribution with an n of 5. We were flipping the coin only 5 times. And then what happened to the sampling distribution when we flipped the coin 50 times? So when we upped the sample size, we got less sampling variability. Less variability means a smaller confidence interval. So the other way that we can keep the margin of error low while still having a high confidence level is by making sure that we have a large sample size. But a lot of times we don't just go out and take a sample, right? We decide on the size before we go out and do it. Right? We need to know when we're done. How many people do we need to sample? Are we sampling 20? Are we sampling 100? Are we sampling 1,000? We should know that ahead of time. So we're going to use the calculations from the confidence intervals to figure out how large of a sample size we should have if we want to achieve a certain margin of error with a certain confidence level. So remember that the margin of error formula was the second half of that confidence interval formula. The plus or minus part was the z star times the square root of p hat q hat over n. Well, if I know what the margin of error is because that's what I want to achieve, and I know what z star is because I've already decided the confidence level as well, then what I'm looking for is the sample size n. And if you are a math major, I would really like it if you would take the time to take this formula and solve for n and show that when you solve for n, you get this. If you're not a math major, please don't take the time to do that. It's just algebra, and only math majors would find it really fun. So, but I do want you to make sure that you write this down in your notes and have it handy, because this is the formula that you're going to need when you're finding the sample size. So the sample size is going to be p hat times q hat times z star over the margin of error squared. So make sure that you have this. You're also, please note that whenever you get your answer, we're going to round it up. Regardless of what we get for the decimal, we're always going to round up to the nearest whole number because we're talking about a sample size, so we don't want a portion of a sample individual. But we also want to ensure that we're getting that margin of error. Even if it's by just a couple of decimal places, we want to make sure we're achieving that goal of the margin of error. And it's always better to sample one too many than one too few. And then finally, a quick note about p hat. So sometimes we have a former p hat. There's a sample that's taken before, but maybe it was too small or too big, but we have an idea of where p hat might be. Then we're going to use that as an approximation. But there's other times when there is no previous sample. And when there's no previous sample, we're always going to use a p hat of 0.5. This will give us our largest sample size. Because if p hat is 0.5, then q hat is 0.5. And if you play around with the numbers, that will be the largest values that you can have when you put a p hat and a q hat together. So let's do an example. So remember that we had a survey of 800 music teachers, and 632 of them said that music education has a positive effect on academic performance. let's estimate the sample size needed so that a 98% confidence interval will have a margin of error of 2.5%. So this is the 632 over 800. That was our previous sample proportion. And so we're going to use that when we use this formula here. So let's look at all of the information, all of the known variables. So we know that the margin of error, I abbreviate with ME, is going to be 0.025. We always want to write as a decimal instead of a percent. The p hat is going to be from our previously drawn sample, which was 0.79. And then z star is going to be, we're using a 98% confidence interval. So the center 98%, if you have the newest model and if you have an older model, then you have to use the full lower bound. So if you take that 98%, you have 2% left over, cut it in half, it's going to be 1% below that. We also have that chart a few slides back that I told you to write down so that you don't have to do these calculations and you can just grab the number off that chart. Please feel free to just grab the number off the chart. Okay, so let's use these values and plug this into our formula. So we'll have that the sample size n is going to be p hat, which is 0.79, times q hat, or 1 minus this, which is 0.21, times z star, which is 2.326, over the margin of error, which is 0.025, squared. Don't forget the squared. I think a lot of, excuse me, a lot of people forget the squared. You can put this into your calculator exactly as you see it here. And when you do that, for this problem, you're going to get 1,436.104. And remember what I said before, we always round up regardless of what the decimal place is because we want to ensure that we're going to have a margin of error of 2.5%. So it's always better to sample one too many than one too few. So we're going to round this up to 1437, and that will be our answer for the sample size. Let's try a similar problem. This one says that we plan to sample parents in order to construct a 98% confidence interval for the proportion who believe that physical education has a positive effect on academic performance. Estimate the sample size needed so that 98% confidence interval will have a margin of error of 2.5%. So we have the same confidence level, we have the same margin of error as before, but unlike the previous example, we have no former p hat. We have no older sample proportion that would give us any kind of idea of what we should use for p hat. So remember, if we don't know what to use for p hat, that we use 0.5. We're using the same formula. Again, we know the margin of error is 0.025. Because we have no previously drawn sample, our p hat is going to be 0.5, which means q hat is 0.5. And again, we have this z star. I'm just writing down the steps here, but definitely grab it off of that table that I have it on the previous slide. And so we'll have n equals 0.5, our p hat, times q hat, which is 0.5, times z star, which is 2.326, over the margin of error, which is 0.025, squared. Again, you can put that in your calculator exactly how you see it, and you will get 2164.1104. Again, we always round up, and so our n should be 2165. So that's how big our sample should be.